Hello class, this is the ghost of Mr. Rosse speaking. I will be walking you through a couple of examples of solving by completing the square. So this is our first example. We have x squared minus 14x plus 74 equals 0. So the first thing we're going to want to do is subtract 74 just to get all of our x's on one side. So that leaves us with x squared minus 14x equals negative 74. And using this formula over on the right hand side, we want to get negative b over 2, which in our case is negative 14 over 2, which is negative 7. So that means that b over 2 squared equals negative 7 squared, which is 49. So coming back over here to the left, we can rewrite our x squared minus 14x as a completed square, which is x squared minus 14x plus 49. And since we add 49 to the left side, we have to do the same thing to the right side, which is negative 74 plus 49. And since we have a perfect square on our left side, that is x minus 7 quantity squared. And that equals negative 74 plus 49, which is negative 25. So we're still trying to get x by itself, so the next step would be to square root our quantity x minus 7 squared. So we got to do the same thing on the right side, so we're going to square root negative 25. And since we do that, that's going to leave us with a plus or minus answer. And on our left side, that leaves us with x minus 7 equals plus or minus the square root of 25. And that is equivalent to plus or minus the square root of negative 1. I'm going to pull that negative 1 out, times the square root of 25. Which that is equivalent to plus or minus 5i. Alright, so now I'm just going to rewrite that. X minus 7 equals plus or minus 5i. And last step, we want to get x by itself, so we're going to add 7 to both sides, which leaves us with x equals 7 plus or minus 5i. And 5i and 7 are not like terms, so they cannot be combined, so that is our simplified answer. Alright, this is an example of having an imaginary solution. So now we'll do an example of completing the square with a quadratic that has an odd b value. So if you look at our quadratic here, this is our b value. It is odd. It is 3. So the same steps still apply though. We already have our x's on one side, so we'll begin by taking b over 2. And in our case, that is negative 3 over 2. So that means that b over 2 squared is equal to 9 over 4, 9/4. Alright, so let's rewrite this equation on the left side as a completed square, which is x squared minus 3x plus 9 over 4. And that equals 4 plus 9 over 4, because we added 9 over 4 to the left side. We've got to do the same thing on the right. Alright, so our completed square on the left side factors down to x minus 3 over 2, which is what we got for our b over 2 over here. So x minus 3 over 2 quantity squared equals 4 plus 9 over 4. And so I'm going to simplify that a little bit. 4 is equivalent to 16 over 4. All I did there was get a common denominator. So I can add 16 over 4 to 9 over 4, and that will give us 25 over 4. So I'm just going to bring that down, rewrite everything that we have. X minus 3 halves quantity squared equals 25 over 4. And now we're just solving by square root. So we'll take the square root of both sides. And make sure to write that plus or minus because it could be either or. Alright, so that leaves us with x minus 3 over 2 equals plus or minus the square root of 25 over 4. But since those are both perfect squares, 25 is a perfect square and 4 is a perfect square, that the square root of 25 over 4 is actually 5 over 2, 5 halves. Alright, so we have x minus 3 over 2 equals plus or minus 5 halves. Still want to get x by itself, so I'm going to add 3 halves to both sides. And that leaves us with x equals 3 halves plus or minus 5 halves. So we can think of that as two separate equations for x. X equals 3 halves plus 5 halves, and x equals 3 halves minus 5 halves. So for our top one, that'll give us 8 halves, which is equal to 4. For the bottom one, that'll give us negative 1 or negative 2 halves, which is equal to negative 1. So our final answer is written as x equals 4 or negative 1. All right. And for the last example, I'm going to do completing the square problem where the a value is not equal to 1. So in this case, I'm going to rewrite the equation as negative 3x squared, just to get our x squared term first, plus 6x equals negative 12. And again, we want our a value to be 1, so let's get that negative 3 out of there by dividing every term by negative 3. And that will leave us with a much simpler quadratic of x squared minus 2x equals 4. So coming up to our equation on this on the right side, we need to find b over 2, which gives us negative 2 over 2, which equals negative 1. And therefore, b over 2 squared is 1. Negative 1 squared is 1. So the next step is to rewrite this on the left side as a completed square. So x squared minus 2x plus 1. Since we added 1 to the left side, we got to add it to the right side as well. So it leaves us with 4 plus 1. And our completed square root on the left side factors down to x minus 1 quantity squared. On the right side, 4 plus 1 is 5. Now I want to get rid of that squared, so I'm going to square root both sides. And I got to make sure to write that plus or minus with that square root of 5. So we're left with x minus 1 equals plus or minus square root of 5. I'm going to bring that 1 to the other side by adding it to both sides. And that leaves us with x equals 1 plus or minus the square root of 5. And that is as simple as that answer will get, so that is your final answer. Alright, those are 3 examples I'm doing for you. Have a good Friday, guys.